Q3887. What constitutes the payload of a balloon? A. Total gross weight. B. Total weight of passengers, cargo, and fuel. C. Weight of the aircraft and equipment. The correct answer is B. The payload of a balloon includes all the items or entities that are carried on board and contribute to the overall weight. This typically includes passengers, cargo, and fuel. The weight of the passengers refers to the combined weight of all individuals who will be on board the balloon during a flight. Cargo refers to any additional items, such as equipment, supplies, or luggage, that are being transported in the balloon. Fuel refers to the weight of the gas or other substances used to provide lift and control the balloon's altitude. It is important to consider the payload when determining the performance and capabilities of a balloon. Balloons are designed to operate within certain weight limits to ensure safe and efficient flight. By taking into account the total weight of passengers, cargo, and fuel, balloon operators can make appropriate calculations for factors such as lift, fuel consumption, and maneuverability. In summary, the payload of a balloon consists of the total weight of passengers, cargo, and fuel being carried on board during a flight. 2174. Problems caused by overloading an aircraft include A. Reduced climb rate, excessive structural loads, and shortened cruising range. B. Increased service ceiling, increased angle of climb, and increased cruising speed. C. Slower takeoff speed, increased maneuverability, and shorter takeoff roll. The correct answer is A. Overloading an aircraft severely degrades its performance, safety, and efficiency. The primary consequences are reduced climb rate. Excess weight increases drag, which makes it much harder for the aircraft to gain altitude and lowers its overall service ceiling. Excessive structural loads. Pushing beyond the designed weight limits places dangerous stress on the airframe, wings, fuselage, and landing gear, risking premature wear or catastrophic structural failure. Shortened cruising range. A heavier aircraft requires more power to maintain level flight, which burns fuel much faster and significantly reduces the total distance it can travel. 2182. Most aircraft are so designed that if all seats are occupied, all baggage allowed by the baggage compartment structure is carried, and all the fuel tanks are full, the aircraft will be A. Grossly overloaded. B. Under maximum gross weight. C. At maximum gross weight. The correct answer is A. Most aircraft are designed in such a way that if all seats are occupied, all allowable baggage is carried in the designated compartments, and all fuel tanks are full, the aircraft will be grossly overloaded. The maximum allowable gross weight for an aircraft is determined by its design considerations, taking into account factors such as structural integrity, performance capabilities, and safety margins. While the maximum allowable gross weight is established based on design considerations, the maximum operational weight may be lower due to various factors. These factors can include high-density altitude, which affects the aircraft's performance in thin air, and high-drag field conditions caused by wet surfaces on the runway. Additionally, the maximum gross weight may be limited by the length of the departure or arrival airport's runway. When preparing for a flight, it is crucial to consider the distribution of the load within the aircraft, not just the overall weight. The center of gravity, CG, must be maintained within the limits specified in the pilot's operating handbook, POH, or Aircraft Flight Manual, AFM. Proper weight distribution helps ensure the aircraft's stability, maneuverability, and control during flight. In summary, when all seats, baggage, and fuel are loaded to their maximum allowable limits, the aircraft will be grossly overloaded, exceeding the maximum operational weight for safe flight. 2183. When operating an aircraft, the pilot in command is responsible for using A. The most current weight and balance data. B. Weight and balance data from the factory. C. Recent weight and balance data. The correct answer is A. When operating an aircraft, The pilot in command is responsible for using the most current weight and balance data. The weight and balance of an aircraft are critical factors that directly impact its performance, stability, and safety during flight. To ensure the aircraft is within its allowable limits, the pilot must have accurate and up-to-date information regarding its weight distribution. Weight and balance data can vary over time due to changes in equipment, modifications, repairs, or alterations made to the aircraft. Therefore, relying on weight and balance data from the factory or previous records may not reflect the current configuration of the aircraft. To determine the aircraft's weight and balance, the pilot in command should consult the most current and accurate sources of information, such as the aircraft's pilot's operating handbook, POH, weight and balance manual, or other authorized references. These documents provide specific calculations, charts, and instructions for determining the weight and balance for a particular flight. By using the most current weight and balance data, the pilot in command ensures that the aircraft is loaded properly, maintaining a safe center of gravity and staying within the prescribed weight limits. This practice contributes to the overall safety and performance of the aircraft during operation. 3289. If the outside air temperature, OAT, at a given altitude is warmer than standard, the density altitude is A. Equal to pressure altitude. B. Lower than pressure altitude. C. Higher than pressure altitude. The correct answer is C. When the outside air temperature, OAT, at a given altitude is warmer than standard, the density altitude is higher than the pressure altitude. Density altitude is a measure of the density of the air, which affects the performance of an aircraft. It is calculated by taking into account the pressure altitude, altitude above the standard datum plane, and the temperature. Warmer temperatures cause the air to become less dense, meaning there are fewer air molecules in a given volume. As a result, the density altitude increases, even though the pressure altitude remains the same. This has an impact on aircraft performance because the reduced air density affects factors such as engine power, lift, and propeller efficiency. Therefore, when the OAT is warmer than standard, the density altitude is higher than the pressure altitude.